pull up your test. Now, that being said, if you guys scored less than 80%, I always forget the number here. I want to say it's 80%. We ask you to retake them, and we're only going to test you on the questions that you guys missed. So,
when did you let us know?
Tonight, I'll have the graded test in your folder. So,
okay.
So yeah, just at that point, you need to you just need to let me know when you're ready to retake. We can stay on a little later, or we can even do it before class. I can let you retake the questions that you missed. But yeah. Any questions on that or about the FARs quiz? Do you guys have questions about like any of the navigation stuff that we've gone over? Let's see. So you guys have looked at all the charts. You guys have talked about the airspace system. We did the navigation PowerPoint. Let's see. Cool. You guys feel like you're understanding the material, or?
Yes. Yes, but I think it's a lot. And, like, it's hard to remember all of it.
Mm-hmm. It definitely is. It is a lot. But just to give everybody a little boost of confidence here, remember that you don't have to know everything right off the bat, right? We go through a lot of material, and we want you guys to study and understand the material that we're giving to you guys. But don't feel like you have to have like an in-depth knowledge of how everything works, right? The good thing about this class is that we're giving you the basic tools. So when we give you quizzes, those quizzes, the collective of the quizzes that we give you, are going to equal the practical. Okay, these quizzes are all actually the oral part of the practical test. So when he's asking you guys questions and stuff like that, asking you to identify certain things, that's what we're covering in this class. That's what we cover on the quizzes. As far as like the other stuff, a super basic knowledge is all that's required. Okay. When you guys go to an airline, at that point, that's where we really start to get an in-depth knowledge. The training programs, there's a lot of really good regionals out there. And I know SkyWest, even just in the airline industry overall, for an example, because I know SkyWest's training program has been ranked one of the best training departments in all of the airline industry for dispatchers. So, and Adam can back that up. Adam probably has a little more knowledge about that, but that's where you guys are going to really start breaking into these things and really start to get that strong grasp that you need. Okay. And then it's not like they just dump you out on the floor and expect you to have everything memorized. The first 2 months of your training on the floor, you have a dispatch trainer sitting right next to you. You act as what they call a dispatch assistant, or an assistant dispatcher. I'm sorry. Kind of. That's your role. And so they sit there. They'll talk to you about, navigational aids. They'll talk to you about route building, stuff like that, and you'll get used to the system that SkyWest uses, all the different programs. You really start to get a deep understanding at that point. Now, that doesn't mean be lazy in this class, because it is a lot to take in. There is, an expectation that you guys have a good grasp of the basics, but don't feel overwhelmed by the material. Just when we tell you guys this is important, make sure you take notes on that, and you guys will do just fine. Me and Adam, since we've been teaching, we've only had one person in 6 years that has had to retake the practical. Okay. So, and it was just a retake. It was pretty simple. They passed the second time. Okay. So we will make sure that you guys are ready. And we talked about in the FARS that there's a requirement that 80% of all the students that we present and recommend for the practical test, 80% of those students have to pass the practical the first time, or else they could technically shut down the school. The FAA can. So, just know that we are in your corner. We're going to help you guys get through this. If you ever feel overwhelmed, let us know. Ask questions, because that's what we're here for. That's what we want to do for you guys. And we understand. We've been in your shoes. Adam and I, Davis, Derek, we've all taken this training. We all know it's a lot, and we're going to do everything we can to help you guys out. Okay. So just stick it out. You guys will be good. Not a lot to worry about. Just keep your head in the game, and we'll get through this. So, but like I said, if you guys ever have any sidebar conversations, you guys can stick around after class. If you want to talk like this before class, just let us know and we can jump on a little early and talk to you guys. I'm going to put in the chat box my cell phone number so you guys can text me. I forgot to do that the first day. So that's my telephone number. You guys can text me, call me if you have questions or concerns. And and yeah, we'll get you guys through this. But yeah, that's kind of my spiel on that. Okay. So I kind of feel like, do you guys, have you guys played around with that Skyvector? I know I've showed you guys. I think Adam, did you play around on it with them last night? If you're near your computer.
We didn't really. Well, we used it in kind of looking at the VFR sectional chart and the IFR high and low charts, but
Okay.
we didn't really necessarily talk about how it works and the functionality and where to how to navigate like with your mouse and things like that.
Okay, cool.
So But there, yeah. So we were gonna. There's another video from last night's class that we didn't get to that just talks about the kind of the intro to Skyvector. Or it's not, you don't necessarily have to watch it, but you know, you can obviously just give a demo as well. It's pretty easy to use for everyone. So
cool. Yeah, I'll run through it. You guys know where he's talking about on your Google Drive. If you come into day 3 into this links tab here, if you guys click on this link right here, this is the YouTube video. They demonstrate it. I'm just going to show you guys some of the functionality of it. You guys can YouTube it. Get very comfortable with this program. This program is excellent. You can, if you buy the subscription, which you don't need to for this class, but let's say you're an actual pilot. I know we've got some of those in here. And you go flying and you want to file IFR flight plans, you can do that directly from this program. You can put in speeds. It will give you actual like ETAs for your legs and stuff like that with the current weather. This program's it's super amazing, makes life easier. And with our new dispatch inspector that we have that's going to be over that's over, kind of has jurisdiction over this school. He's opened it back up to where you guys can use this on your practical test, which is super nice. This cuts down, I mean, it's the same exact as if you were using a paper map, but it will cut down the actual time it takes for you guys to do your practical by probably 2 hours or more. I know my students that took the class the first time had to use the paper maps, and some of their practical tests were like 5-6 hours. But my last class was able to use Skyvector, and their average practicals were like 3 to 4 hours. So it's super beneficial for you guys. Okay. You guys have been learning about navigational aids. We've broke down IFR charts, the en-route highs and the en-route lows. We've showed you guys a couple VFR charts. We're going to dive into the terminal structure, terminal environment tonight. We're going to talk about that as well as some other things. And so this might not make complete sense to you guys, but let's look at the functionality. Let's break it down a little bit, okay? So I know we've talked about how whenever you file a flight plan, remember this is on the FARs, this is one of the 3 things that the pilot has to have with him in the airplane whenever he's flying, right? So let's see if I can zoom in just a touch here. Okay. This IFR flight plan, this software helps us build that flight plan, and then it also will help us like get times, you know, all of that good stuff that we need. Okay. So this box right here, if we click this flight plan box, this pulls up. We can shut it down. We can click it. Okay, this is our flight plan box. This is where we put our departure airport and then our destination. So let's say we're going from Denver to Salt Lake City. Okay, we can put that in the box, and then look at that. It gives us direct Denver International Airport to Salt Lake City International Airport. Okay, pretty neat. From here, we can click on this. We can pull up charts. We can pull up just a whole bunch of fun stuff. Okay. That being said, these charts we don't really want you guys to use. These are all NACO charts. Down here at the bottom, we're going to give you guys the Jeppesen charts. We talked a little bit about the difference there. 99% of the airlines, 90% or better of the airlines out there use Jeppesen charts. So we're going to get you guys really comfortable and familiar with Jeppesen charts. But if you just want a quick reference to what runways are available, what approaches, you can see here we've got our instrument approach procedure charts. Okay, so you can look and see what types of approaches they have available. We can look at our departure charts. Okay, we call these SIDs. Okay, these are how we transition from the airport. So when we take off, this is how we get to that en route environment. That's what we call it. So each one of these planes, rather than planes just flying directly to their destination, kind of like we see right here, planes never fly direct like that, and unless there's very special circumstances. What we do is we'll separate. Air traffic control comes up with these departure procedures where they will tell, we've got these charts down here, and this puts everybody that's departing in a certain direction on the same flight path. Okay, so this just keeps it nice and tidy for them. So if they're flying down to the south, we can pull up, excuse me, we can pull up this chart, and if we use the Pikes 9 departure, this is how we get from where we take off to that en route environment, okay, where we're cruising along, flying to our destination. So that we don't have any, so we relieve some of that pressure off of air traffic control. They put everybody on these same highways. You can look at these as like, neighborhood streets. Okay. We also have up here, we have what we call star charts, okay? Standard terminal arrival. These are just like the departure procedures or the SIDs, except for it's on the other end. This is when they're coming in to land. They get everybody that's coming in to land at that airport lined up on the same exact route, okay? So this is coming in. If we flip this chart 90 degrees to the right, rotate clockwise, there we go. Okay, you can see on this chart, you got this north arrow. Okay, so this is coming in from the southeast. These are the VORs, those navigational radio stations. This is where we would fly over to get to Denver International if we were coming from the east southeast, okay? And we just fly this route all the way into Denver International Airport. So this is how air traffic control spaces everybody out and gets everybody coming in the same direction. Oops, that was dumb. Okay. So anyways, there's our departure destination. Another thing that's kind of cool about this is that we can go to this chart supplement. This is where we find what's called the AFD. Okay. This is our airport facilities directory. This gives us tons of information on the runways and the lighting and the lengths, stuff like that. So we can see that they've got runway 16 right, 34 left. Okay, we know that those are 16,000 feet long and 200 feet wide. We know that it's concrete, it's grooved. This is the So, trying to find the right words here. Oh my gosh. I can't remember. It's something that we don't use ever. But anyways, so this just tells us that it's got hurls and centerline lights. Okay. This other information, I can't remember exactly what. If you remember, Adam, I can't remember what those numbers are. Anyways, you can see runway 16 right here has Mausers. Okay. This is our approach lighting system. So if you look at 16 right, here's 16 right. This is a kind of an aerial shot of the airport here. Runway 16 right, the approach light system here is what we call a Mauser. Okay. And it's got touchdown zone lights. So this tells us where the end of the runway is. This is where we want to touch down. Okay. It also says the PAPIs are on the right side of the runway. Okay. And this is telling us our glide slope is at 3%. The touchdown zone is 71 feet. I don't know what. But then it has an RVR. Okay, RVR is what we call runway visual range. And what that does is it measures the visibility from one end of the runway to the other end of the runway. Okay. How much weather visibility do we have? How far can we see looking down the runway? Okay. So all this information just gives us a lot. It just gives us a breakdown of each one of the runways. Okay. You can see that runway, looking at this aerial view, you can also see that runway 16 right is the longest runway in the airport at 16,000 feet. Okay. It's 3 miles long about. You can see all these other ones are 12,000 feet by 150 feet wide. So there you go. You can see the basic layout of the terminals. You can see where the tower is, all of that. Another cool feature is down here. This is that view that we were just looking at, that top-down view. It gives us a little more in-depth information than just that really basic one we were just looking at. Okay. Oh, here's what those numbers were. Okay. So this is telling us like the elevation of this runway at the end is 5350, so 5,350 feet above sea level. This one's 5,322 feet, so on and so forth. You can see all of that. Once again, here's our runway lengths. Okay. Let's talk about runway direction really quick. So, going back to that compass rose. Okay. The video that we showed you guys when was it? Thursday last week. Yeah, Thursday last week. It talked about basic navigation. So here you have a compass. Everybody's seen a compass, right? At the top, you have due north, which is 360 degrees. So geometry, right? A circle is 360 degrees. half of a circle. If we were to split this circle in half, this is 180 degrees. Okay. So this is due north. This is due south. We got our east and west here. So east is at 90 degrees. This is due east. And that makes due west 270 degrees. Okay. So here's how runways are laid out. You can see that this runway is basically, it's pretty close to if we look here, this is telling us, orienting us as to where north is. We know that north is that way, the top of the page here, right? This is telling us our magnetic variation. So it's 8.4 degrees east. So when we're looking at our magnetic compass, we're actually going to offset that. And remember, east is least, so we're going to offset our magnetic compass, whatever direction. We're going to take away 8.5 degrees from whatever it's telling us. So if it's telling us 270 degrees, we're going to subtract 8 from that. That means that what we'll read on our compass is 261.5 degrees. Okay. So this is the way the runways are oriented. So let's look at runway 8 and runway 26 here. Okay. If you were landing this direction, you are landing on runway 26. Okay. What direction is that runway heading? What direction are you flying if you're landing on runway 26?
West.
You're headed almost due west. Okay. So that being said, the actual runway heading is 262.1 degrees. So if you were to take an actual measurement as to what direction this runway is heading, it'd be 262.1. So all the FAA or aviation guys do is just like everything else. We take what numbers we want to see, we simplify it a little bit. Runway 26 is 262 degrees. So if we are going to land on 26, we're going to be flying due west almost, and that's the runway we're landing on. Runway 8 is we're headed this way, right? So it's 080 degrees. All we do is we take off the 0, take off the last number there. We're landing on runway 8. Okay. That means that we're going to be landing flying due east. Pretty simple. Does everybody understand that?
Yeah.
Anybody have questions on that? Okay. This translates directly into winds. Okay. Whenever we're looking at a forecast of winds, we may see 27015. Okay. If we see this in our METAR, that means the winds are coming from 270 degrees at 15 knots. Okay, we just break it right there. These two digits will always be the wind speed. Okay. Wind speed. Maybe I am getting a little bit better with this writing with a mouse. Sometimes it gets pretty horrible. Okay. So, what direction?
Hey, Garrett?
Yeah.
Sorry, real quick. So with the runway direction, like for example, the one that you've got highlighted, runway 26.
Mhm.
Is that actually at 260, or is that actually almost dead on 270, but it just says 260, and you adjust for the magnetic variation, and so you're going to put in 26, but you're really going to be at 27 because of magnetic variation?
No, so this one, I erased the last two numbers here. The actual runway heading is 262.1 degrees, so they round that to the nearest tenth to give us our runway number. Does that make sense?
Okay.
So you can see that down here as well. Runway 35 right is 352.1 degrees. So that's that's corrected for variation and everything. This is your magnetic heading will be 352.1 degrees.
Okay, and I guess that's what I was wondering, is if you're adjusting for the magnetic heading, so the actual runway will be actually almost 360, or will it actually be laid out at 352? I guess I'm curious.
Yeah.
I'm confused about what the actual true north is versus what the variation, where it's varied.
Yeah, so this is always going to be, all of the information you see on these charts are going to be in magnetic, using magnetic north. Okay, because when you're in the aircraft, all of your instrumentation is set up for magnetic north. Okay, because we read all of our information using magnetic north.
So if you were flying in and you had your magnetic north inappropriately set at 0, then you would be basically 8 degrees off of 352. So you need to adjust 8.4 degrees east to make sure that your magnetic compass now reads 352 and you hit the runway straight.
So your magnetic compass, it's a needle in a floating, in a water case. So that's always going to point directly at magnetic north. True north is calculated. True north we don't really care about. We just know that there's a variation between magnetic north and true north. So magnetic north, actually, yeah. So magnetic north is what the pilot actually reads in his cockpit. True north is, we know that there's that adjustment depending on our location. Does that make sense?
Yeah.
Okay.
Yeah. So I mean, if you're just going to say that we don't really care about true north, that actually helps.
Well, we do care about true north because when we're using our maps, so this is getting a little complicated here.
Sorry, I don't mean to.
No. It's good. I'm glad these questions are being asked, but so these lines of longitude here, longitude and latitude, okay? The lines of longitude and latitude are all pointed at true north. You can see this is all pointed at true north, okay? Does that make sense?
Yeah.
So when we actually put our measurement device on these maps, and we don't put them on these charts are different. But if we were looking at a VFR chart, when we put our VFR chart, I take that back. All of our maps are in true north and corrected, and we correct for our magnetic variation. I'm sorry, I just added another layer of confusion. Okay. Okay, so reverse what I said. Everything's in true north. We account for magnetic north. So our magnetic compass will read different than this. Does that make sense?
So we want to adjust our magnetic compass to get it to read 352 when we're coming in.
Well, we
to
don't
the
we don't
runway.
make any adjustments. We just know that there's
Or okay. Okay.
um
All right.
yeah, so our instrumentation is already set up. Like the magnetic north is already set. Our other instrumentation, the navigational radios, okay, those are all set to magnetic north, and so it's already our as far as our navigational radios are set up, they're all set up to um, yeah. This is so hard. If we were in a cockpit, it would be so much easier to explain this. But um, yeah, when we're tuned into our VOR, we're going to get the true north reading. When we're set up, or when we're reading it and interpreting from a map, we're using true north, and then we'll adjust for magnetic variation if we're navigating by compass. But everything else is being, you're using true north. Does that make sense?
Yeah, I think so.
So we use true north on all of our instrumentation except for our magnetic compass. Does that make sense? It's fairly complicated. It makes sense when you're in a cockpit, but
Yeah, well, and part of the problem I'm having is, and the reason is that right now today I happen to be going over the navigation section in Shepherd Air, and so a lot of these questions are coming mostly so that I don't screw myself up when I'm trying to remember what the answers are.
yeah. That's the bad thing about aviation is like with airspeed, there's like 5 different types of airspeed. With navigation, you've got magnetic north, you've got true north, you've got what is it called? What's the calibration that we do for the aircraft? Like the engine in the aircraft, the metal in the aircraft throws off the compass a little bit too, and we have to have the magnetic compass, or we have to have a placard in the cockpit that tells us what the deviation is with the actual aircraft that we're flying. Like there are so many variables in aviation. All we need to know is that we're using true north in our navigation. Okay. So when we're going through and we're doing our flight plan, everything will be used. We'll be using true north. We won't adjust for magnetic variation. We'll just always use the true north. Or yeah, we'll be using everything that we're reading on our maps is already adjusted and corrected. So we'll just use the information directly from the map. So let me show you guys that. So this is all already adjusted and corrected. Let me see. Let me get back to where our flight plan is. So this one right here, if you look at the heading for our route, you can see that it says 274 degrees and 340 nautical miles. This has already been corrected and adjusted for any magnetic variation or anything. So this is what the pilot will actually fly, is a heading of 274 degrees. Okay. This is like all of your corrections are done already. Does that make sense?
Yeah, it
Yes.
does.
So just read this information as exactly as it is. Don't ever try to correct it. You just add a layer of confusion in that doesn't need to be there. And that's one of the beauties of this software is we don't have to go in and adjust for everything. That's a pilot thing. You know, we when you're flying, like we call it dead reckoning. We fly, like we'll have to go in and flight plan all this garbage and correct everything for our winds, for like all of that correction will go in. And then, yeah, we'll break down all the magnetic variation, everything like that. As for this class, we'll just read this as what it is, okay? 274 degrees. Now, that being said, at the end of the day, when we're actually flight planning, I'll show you the IFR flight planning form here. Let's see. Let me go into so this is the packet we'll fill out. Okay, although we aren't correcting for magnetic variation, so we'll get the magnetic heading here. This magnetic course, this is what we're going to read, right? The only thing that we're going to adjust for is our wind. Okay, and that gives us the magnetic heading. So you got true north, you got magnetic course, you got magnetic heading. And then there's like other ones, but we don't care. All we're going to do is we're going to take that number that's on the map here, 274 degrees. We're going to put it in here. We're going to put in our wind speed. We'll use a special computer called an E6B. We'll put in our winds and our distance, and then it will spit out our winds and our speeds, and then it'll spit out a magnetic heading. We call it a wind correction angle. Okay. Once that's all done, that's literally the only thing that we will adjust for is that winds, our winds. Okay. Everything else, just read it as it is. Okay. And don't even worry about that right now. This is like dispatch 1300. We're still on dispatch 1010. So, but we'll get there. So let's go back to this chart. That's another nice thing is that you can just kind of hover over the airport and it will give you the charts as well. Okay, so runway heading, we know that is set up for runway 26, runway 8. We get the runway heading 26. The heading of the runway is 260 degrees approximately. This gives us an actual number right here, but we just know that 260 degrees is generally what the heading is. Okay, let's go back to talking about our winds and our weather. So we had 270 at 15. Okay, what this is saying is this is our wind direction. Wind direction. And this one's our wind speed. Does that make sense? Okay, so when we say wind, when we're reading our weather report, it says winds 270 at 15 knots. That means that the winds are coming from the west and going to the east, okay? So we would land on runway 26 because we always want to land with a headwind. Hold on 1 second. It sounds like my kids are killing each other. All right, really sorry about that, guys. Okay, so back to wind direction and speed. So, like I was saying, let's pull up just to solidify what I just said. Let's pull up a METAR. Okay, here we have our METAR. Our METAR says this section here. This is our winds. Okay, winds are 260 at 12 knots. Okay, all you need to do whenever you're decoding these winds on the METAR, just take the first three numbers are direction, last two numbers once again are speed. Okay, really simple. Remember that this means that the winds are coming from the west, going to the east. Okay. So it makes it really easy for us when we're trying to decide what runway we're going to be using, because we always know that this number, whatever this number is, this 260 degrees, when we're trying to select what runway do we use, and I really wish I could, when we're trying to select which runway we're going to use, you can see we have, a lot of runways here. All we need to do is line up our winds with that 260 that we saw in the wind report. We'll just line it up with whatever runway is pointed mostly in that direction, because that's going to give us a headwind. We try to always land with a headwind. Okay. It helps slow the aircraft down. It helps create a little bit more lift for the airplane. So we always try to land with that headwind. So we would use runway 26 in this case. Everybody understand that?
Yes.
Yep.
Yep.
All right. So you guys have seen some really cool features of Skyvector right there. Okay. Here we can always put in a speed. We don't, the only information that we ever want to use when we're using this software for flight planning is going to be our distance. Okay. We don't care about our time. Okay. This is time corrected for our winds, and so the current winds, the flight plan packets that we give you, we're not ever using current winds. We always use weather reports from a long time ago, or from, we'll make up our own weather reports. So we just never use this time right here. But this distance, this gives us the total distance from our departure airport to our destination. Okay. Here, this box here, this is where we type in our legs, or what we call them. Okay. So if let's say that we wanted to go from Denver to Salt Lake City, we would choose our departure procedure, and then we could put that in here. So I can drag and drop. If I click on this right here, I can drag and drop my route, and then I can come over here. This is the Falcon VOR. I can click on that plan, and it plans that, and you can see that it automatically plans my departure procedure and we call this transition point. Okay. And then I can just go through here. I can plan each one of these VORs. You can see it's already planned my arrival procedure. So Denver 9 to Falcon VOR, on J116 to Meeker VOR, and then the Spain 7 arrival. You can see it plans it all out for me. Pretty neat software. Pretty cool. This nav log here, I mean, we just looked at this, right? Looks pretty familiar. Okay. This nav log gives us a breakdown of each one of these legs. Okay. Now, that being said, all of this information, remember, is going to be using current winds. It's going to be doing a whole lot of stuff that we don't want you guys doing. So the only information that we're ever going to pull off of this, that you guys are ever going to pull off of this, is the distance, pretty much. If I can find it here. Okay, right here. So this is the distance from Denver to Falcon VOR, 10.6 miles. From Falcon to Meeker VOR, 154.3. To Racer, 44.2. To Mighton, 57.3. To Thistle, 50 miles, so on and so forth. That's the only information we want you guys to use. All this other information is just like, if you were to actually file this IFR flight plan right now, this is what you would be submitting, okay? But we're only going to use this to get our distances. That's the only thing I want you guys using this for. Right there. I'm just showing you the feature of, because it makes it a lot easier than the other option of like coming in here. You know that you're going from Falcon to Meeker VOR. If you look here, this is the total distance, 154 miles. Another cool thing is you can hover. Where's that? Oh, right here. So Falcon to Meeker VOR, if you hover over that J116, it will highlight, do that dark magenta over that section. It will tell you your distance if you hover over that section. So we know that it's 154.3 nautical miles. Okay. Once again, ignore the time on it. And then, yeah. So pretty cool stuff on this flight planning software. It's free. You don't have to pay the subscription. So at any point, if it asks you to, if you want to buy the subscription, tell it, just say no. You don't have to have a subscription to use this software. We can also click, so this was all using the world high en route charts. We can also use the world low en route charts. So if we click on that, remember this takes us down to our low VORs. Our low VORs are just, it gives us a lot more options as far as transitioning from point to point. There's typically a lot more detail. It's a lot closer view of the Earth, I guess you could say. So, yeah. So you got your world high, and then, oops, our world low. World high, world low. So our high charts are what we typically want you guys using for most of your route planning. When you get closer to an airport, we might have to switch to the world low just to get us onto a jet route. So remember, this uses the Victor routes. The world high uses the jet routes. So we want to stay on jet routes if we can. Sometimes we have to use the Victor routes to get to a jet route, to get to a VOR that's we can use that has a jet route going off of it. Like I said, I don't really want to get super in depth into flight planning right now. We'll get more involved with that later in the class. But yeah, it's kind of a breakdown of how to use this Skyvector. Like I said before, if you click on this charts here, and here's all of your, this is how, if you were to use a paper chart, this is, you know, the different paper charts. You can see it says like en route H2 up at the top there. Those are your different charts for your paper charts. And if you click on one, you can see how it's oriented. Okay. I know on like the VFR charts, if we look at a VFR chart for Salt Lake City, it gives us a legend, tells us a little bit of information about some of the symbols that you'll see on the maps. Tells us information on our restricted airspaces, also on our MOAs, our military airspaces. But yeah, so that's the charts button. If you guys, it's kind of cool because this remembers your IP address. And so every time you log on, if I were to like shut this down like that, log back onto Skyvector, I don't have to restart from scratch. It automatically saves my last flight plan that I put in. If you guys want to start a new flight plan, you just click this paper with the dog ear in the top corner, and that resets everything. You can save flight plans. I've got, let's see, like I've got this one right here. You can load it up. So pretty cool stuff. And you guys are going to get really familiar with this. Another reason why we don't like you guys using these charts is you can see these are sigmets, convective sigmets. So it's, like I said before, it pulls current weather information. And this is giving you current convective sigmets. These red boxes and circles, these are those TFRs that we talked about, temporary flight restrictions. Okay, you can see there's all of California's burning. And so they've got TFRs for the firefighters, dumping the water on the fires, stuff like that. So we don't want you guys pulling that type of information off of here. We're just using this as a reference in our flight planning. Okay. Make sense? Everybody good? I would highly recommend another thing that oh, I can't. Oh yeah. So hold on, let me load this back up again. You know how we clicked on this nav log? You can also do it here. This will tell you the direction, the heading. This isn't corrected for anything. This is the magnetic course that you see. Okay, so we will pull this off of there. You guys can pull these distances off. So it's nice in that regard as well. And we can switch it back to where it's just like this too. I highly recommend you guys jump on this website and just mess around. You know, if you guys want to fly from, you know, just practice like, okay, Salt Lake City to LAX. Put that in there. Get used to like dragging and dropping it onto VORs and planning VORs. You know, trying to stay on the black lines here. Oh, so this is kind of a good example of sometimes our jet routes take us places we don't necessarily want to go. So we can use a low chart to get us onto a VOR that we want to be on. Then we can switch back to the high. You can see that it puts us on this jet route. And then it gives us an arrival. So, or I'm sorry, departure procedure there. Anyways, just get on there, play around with the software, get comfortable with it. We're going to use it a lot. You guys are really going to get familiar with it, but give yourself a head start. Also use this video in here in the day 3 folder. So week 2, day 3, click on the links here, pull up this YouTube video. It's all going to help you guys when we get to the flight planning portion. Okay. That being said, why don't we take a... are you guys ready for dinner, or do you guys want just a 10-minute break? We can get back on in for an hour and do dinner then. What do you guys want to do?
I could do dinner now.
Okay. So let's jump back on. Let's just say 7:20. Okay. All right. Is everybody back?
Yep.
Yep.
Yeah. Hey, Garrett,
Yeah.
where was your friend going when he saw that, the whatever it was, the dispatch thing?
Oh, I was just messing with everybody.
Oh, I thought that was real.
Yeah.
Would have been funny if it was.
Have you seen like all the chemtrails
Yeah.
stuff? So I'll have to pull it up here just 1 second. Let me pull up the picture I just posted. So this is one of my pilot friends that actually originally posted this, but I found it comical, so there you go. Little aviation humor. Can everybody see that? I don't know how to make it any bigger.
Yeah, I can see it.
Earth flattening. That's pretty good.
So everybody, there's like people that are like hardcore into the government uses. Those aren't contrails; they're chemtrails that you see behind planes at high altitudes. And people believe that, just in case you guys didn't know the background of this, people believe that those streaks in the skies behind airplanes aren't water vapor that's turned into ice or clouds. Basically, they believe that the government uses commercial airplanes to mist the civilians down below with chemicals that they can do like mind control and stuff with. So, anyways, it's a little. There's my deck I just built. It's a little humor, but I don't know. Some people might not think it's funny, but I think it's funny.
I think it's funny.
Yeah. So, we were just talking about SIDS and stars and all that fun stuff. So, now we're going to learn about them. So you guys have basically started at like a really, like, think of this as the world, right? You got the world and you got this satellite above it. Well, satellite perspective looking down on the Earth. The first charts we're going to run into are high altitude charts, those en route high charts. And we're going to run into those en route low charts is the next, like if we were magnifying our zoom there. So start at the high charts, next level of zoom, we're going to go into our low charts, next level of zoom, we're going to go into like, a bunch of VFR charts that we don't care about. Next level of zoom is going to be like our instrument approach procedures and our, SIDS and stars, things like that. So this is like really down to the nitty gritty, like with information. This is the first and the last chart we will use in our flight planning will be these. Okay. Okay. So once again, we've got two different types of approach charts. We've got our NACO charts and we got Jeppesen. Got different types of inoperative equipment. These are going to be like our NOTAMs and things like that. If there's stuff that's broken on the airport, I'm going to talk a little bit about those NOTAMs and what they're telling us. Okay, airport charts, ILS approaches, RNAV approaches. So there's different types of approaches that we use. Okay, so this allows us to transition from these instrument approach plates. We call them plates, or we'll call them charts as well. But instrument approach plates, this is when the pilot is looking at his navigation information or navigation radios, the information that's being displayed on those. This gives him a very precise Like this is where you're supposed to be. This is the altitude. This is the points that you're supposed to be flying over. This is what your instrumentation's supposed to say. This is like the super nitty-gritty detailed information that will allow the pilot to land safely in those low visibility conditions, okay? That's what we use these instrument approach plates for. TERPs, this is just the criteria, okay? This is the standardization. So the TERP sections on the chart, this is where we get our landing minimums and stuff like that. You'll hear us talk about landing minimums a lot, okay? So we've got two different types of instrument approach plates. We've got precision approaches, and the precision approaches are going to be your ILS, your RNAV, your RMP. I would write these down. This section right here, write this information down. So precision gives us our vertical and horizontal navigation. So I'm going to try to draw a runway the best I can using my mouse here. So let's go back to Denver. This is what it looks like in the cockpit as they're coming in to land, right? Got your touchdown zone, your 1,000-foot markers, blah, blah, blah. Okay. Got the PAPI out to the right here. And then you got your Mauser lights here. Okay. So the pilot's coming in to land at runway 26. Okay. If he is using what we call an ILS, now this is just like a VOR, but this, instead of just telling him in relationship as to some point in the sky where he's at, this is telling him an ILS is giving him precision approach data. So on his instrumentation, not only is he going to have vertical guidance, but he's also going to have that horizontal guidance. Think of it as like a crosshair. If he starts moving left of the runway, okay, there's a little needle. If he starts moving left of the runway, the needle will drift to the left. If he starts moving right of the runway, the needle will drift to the right. If he starts getting too low, this bar will get down here further and further. If he starts getting too high, the bar gets up here further and further, okay? So he needs to, this is how he's lining up for the runway. If he's got that perfect crosshairs, that means that he is both on the glide slope and he's lined up, you know, directly down the runway, okay? So that's our precision approach. So what you guys need to know for a test, okay, we've got ILS, we've got RNAV. You can also put on there RNP. And then we've got our precision approach radar as well, so PAR. Okay. So you need to know 3 types of precision approaches, and you need to know that a precision approach gives us both vertical and horizontal navigation. So think of it as that crosshair, okay? Non-precision approaches are giving us horizontal navigation only. So once again, pilots lining up for runway 26 here, okay? Got your center line, got some 1,000-foot markers here, okay? You got your lighting system, your PAPIs, okay? What is happening here is rather than having the crosshairs, the only needle that he has for this is just that lateral guidance, okay? So it's telling him you're left of the runway or you're right of the runway, just that type of information. There's actually little dots here, and each dot tells him how far off the center line of the runway he is. So if that needle drifts over here, he knows that he's 2 degrees left of center of the runway. If he goes over here, 4 degrees, so on and so forth, okay? So the pilot's able to line up left or right. On non-precision approaches, the way he gets his vertical guidance, as you might say, is he's just going to have to read the altitudes on the chart and know that when he's over certain points, he knows what altitude he's supposed to be at. Okay, so which of the two approaches do you think is safer and will allow them to land in lower visibility?
Precision.
Precision approaches, okay? So we prefer, and when we talk about landing minimums, which is the next PowerPoint, we're going to be talking about landing minimums a lot. This is where our job as dispatchers really comes into play, okay? Our ILS here will give us our lowest landing minimums 100% of the time. ILS is the absolute best landing minimums we can get, okay? And I would write that down. ILS gives us our best landing minimums. Okay, so if we have an ILS approach available to use, we're always going to go to the ILS approach. Okay, that's our number one choice. Okay, so non-precision approaches, the landing minimums are going to be a lot higher because we're only getting horizontal navigation. Okay, types of the nav. So here's the different types of. Here's our different types of non-precision approaches, and I would write these down because you're going to need to know 3 of these as well. Okay, you've got, this is a localizer approach. You've got a VOR approach, GPS, NDB. We could also have what we call a DME arc. So, I mean, there's other kinds, but these are the ones we most commonly see. Okay. So yeah, not nearly as good to use, but we always have to have a ground-based approach. So sometimes, our ILS, they may be working on it, and so we may only have a VOR approach into an airport. That's okay, we can use it. Just typically, we're going to see a lot higher landing minimums whenever we have a VOR approach. Okay, another type is surveillance approach radar. I've never seen one on a chart, so we never use it ever. Okay. Oops. How do I make this go away? That's not fun. Hey, go away, stupid thing. What's this? Maybe if I ignore it, it goes away. There we go. Okay. So let's break down the instrument approach here. Okay. So what we have is we have an initial approach fix. Okay. This is a point somewhere out in space that's lining us up for the runway and getting us ready to land on the runway. So our initial approach fix to our intermediate approach fix. This is just getting us lined up, everything configured for us to land at the airport, on the runway, on a specific runway. Okay, each runway is going to have its own procedure, own different types of instrument approach procedure. Okay, so initial, like I said, this is the starting point. This is our star or our arrival chart brings us to this point, and then from this point, this is where we go and land. Okay, intermediate fix. Okay, this lines us up. This is the one that sets us up for our final approach. Okay, so pretty easy, pretty logical setup here. Got your initial, intermediate, and a final approach fix. Okay. And then our final approach fix. We have the way this is identified on a chart. We're going to see that in just a second. Second is a Maltese cross. This is where we start. So up to now, you haven't been using the glide slope of the runway, really. To a point you have, but you're doing what we call step downs. Okay, this is going to be our last step down. So the way this looks on, if you were to like take a vertical snapshot of this, is here's your initial approach fix, right? So IAF, then you're going to step down to another altitude and you're going to hold that altitude for a second. This is going to be your, right here is going to be your intermediate approach fix, okay? And then right here, you'll have that Maltese cross. So Maltese cross is just like a real big, bold, X marks the spot pirate map. X, the treasure, marking the treasure. And this takes you down to the runway. Okay, this final approach fix sets you up on that glide slope, and it's typically going to be a 3% or a 3-degree descent down to the runway. Okay. Sometimes it's more, sometimes it's less. It's all based off of terrain and any obstacles that may be in the way at the end of the runway. But a lot of times we're just going to see a 3% or 3-degree descent down to the runway. Okay. Something else that we're going to see is this missed approach procedure. Okay. On the chart, you'll see this little, you'll see a spot right here where it'll go like that, something like that. This is our missed approach procedure. So this is typically where our decision height or our decision altitude is. This is where the pilot decides, am I going to land? Can I land? Can I see the runway? Or do I need to give it another shot? Do I need to go around? Or let's say there's an airplane on the runway, or, if you're in Jackson Hole, sometimes they get elk and stuff on the runway. This is where the pilot's going to make that decision. Okay, I need to go around and give it another shot, or I need to get out of here and go to a different airport. Okay, so this missed approach procedure, typically what they're going to do is they're going to climb up to a certain altitude, they're going to turn, and then they're going to hold over a VOR until they're able to come back in and start the approach again. Okay.
How often does that happen where they have to hold?
Out
of curiosity.
Yeah. It's not very often. It does happen. I would say it's going to be less than 10% of the flights that you're going to dispatch. You'll see them hold, and probably a total of maybe 1 to 2% that you'll ever see do a missed approach procedure. It's very rare, but it does happen. sometimes on a daily basis, sometimes on a weekly basis, you know. The chances are you're not typically going to even see them unless you're really on top of your flights. There's times where you won't even notice that a guy's done a missed approach because they'll do the missed approach, they'll come back around and land, you know, and it's like 2 minutes added onto their flight. So it doesn't happen too often. So this is that profile I was telling you guys about. Here's your initial approach fix. Come down. It's just too much for the profile to all fit in one spot there. And this is a NACO chart too. Here's your step down, and then you have that Maltese cross here, identifying the final approach fix. And then you see that final approach into the runway. This is where the missed approach will be. This is your missed approach procedure. Okay. You can also see your missed approach procedure up here. This tells the pilots what to do if they have to go around. Okay. This right here, this is that TERPS. Okay, this is where we get our landing minimums. You can see if we're shooting the ILS approach and we're a category C aircraft like the 700 is, this is our landing minimums. We've got 200 and a half mile visibility, so 200 feet, half mile visibility. This is like, so this is our profile. This is how our descent will look. This is how it looks if we're doing an aerial view of the approach, okay? We can see that we approach from this direction. Once we hit this spot right here, this is where we turn. Here's our initial approach fix. Here's our intermediate fix. Here's our final approach fix. And going into the runway. Does that make sense? This is our missed approach procedure. Blah, blah, blah. This is NACO. I don't like the way this is set up, but just to show you what it looks like, this is how it is. Okay. So I'm not going to dive into this. Once again, this is NACO. NACO sucks. But a lot of this information is going to be the same. Okay, a lot of this information is the same. It's just laid out, formatted way differently. So we're not going to get too much into that. We'll look at a Jeppesen chart here in just a second. Okay, straight in approach procedures. This is typically what we're going to have when we're doing an ILS approach. We want straight in procedures because they give us our lowest. Of the ILS approaches, they give us the lowest ILS landing minimums, okay? So we have two different types typically identified on the chart. Sometimes, because of obstacles, we have to do what we call a circle approach. So here's the runway. There's a VOR, or there's something here near the end of the runway that is giving us what we call a DME. We'll circle in, and then once we've circled and lined up with the runway, then we'll turn onto that approach, okay? Circle to land, a lot higher minimums. I know at SkyWest, the absolute lowest minimums you can get circle to land are 1,000-foot ceilings and 3 miles of visibility. Whereas an ILS straight in, we can use 200 and a half. So big difference in our landing minimums, okay? Circling procedures, typically not done. We try to avoid them. We have them if we need them, but we try to avoid them, okay? The only time we use them is if we don't have the straight in landing minimums, okay?
Hey, Garrett, question real quick. If the straight in landing minimums are no good, but the circling has even higher. Is it just SkyWest, or do most airlines have higher minimums for circling? So trying to figure if you can't land straight in, why would you be able to land circling in if the minimums are higher?
So there's times where the ILS has there's three things in an ILS. Okay, there's that vertical, and then there's the horizontal guidance, and then typically you have that DME. Okay, those are three things that make up our ILS. So if one of those is broken, sometimes we have to use that circle to land. Okay, straight in procedures, and let's go back to this, because even though I don't like it, you can see here's your straight in. So straight in ILS for runway 3. Here's your landing minimums, 200, 1/2. You can see that right here. Okay, circling, the lowest that you can see here. Let's say that we're with Delta Airlines, okay, and they allow us to use the actual published minimums on the chart. See, SkyWest, you can't use the published minimums if they're below that 1,003 miles. SkyWest, that's the absolute lowest we can go. Whereas with some airlines, you're able to use this published. So let's say that we're in a CRJ 700 and we're working for Delta, and they allow us to use this published minimums. Look at how much higher that is. So 600-foot ceilings, 1.5 mile visibility, versus the straight in 200 and 1/2. Does that make sense? So
yeah, so it's not necessarily a question of whether, it's more likely a question of system difficulty on the ground.
exactly. Yeah. Like I said, even then, 99% of the time, even if they can't use the straight in approach, they still won't use a circling. They'll use a different type of approach. So they'll switch to like an RNAV approach or a VOR approach or something like that in order to get their landing minimums, because even then, those are typically going to be lower landing minimums than a circle to land. Circle to land is absolute last resort 90% of the time. It's like a backup. It's a redundancy. Okay. Good question. Okay. So the oops. When it talks about this final approach course, alignment from the runway 30 degrees is less than 30 degrees. What it's talking about is your initial approach fix. Let's say this is your runway here. Your initial approach fix is never going to be more than 30 degrees deflection of the runway heading. So you'll always start at 30 degrees or less as you start your circling procedure from your actual runway heading. Okay. Your descent gradient is talking about 400 feet nautical mile, 400 feet and 1 nautical mile from the final approach fix. So you're going to descend at 400 feet per minute, basically. Example, like a VOR A approach. Okay, and we'll, what in the world is going on now? Yeah, there we go. Okay. So at the top, once again, this is NACO, so we're not going to spend a whole lot of time. We have this top portion is called the pilot briefing. This gives them the radio frequency for their navigational radios. This tells them the approach course. This tells them how much runway there is. This tells them the touchdown zone elevation. So this tells them how high above sea level the touchdown zone is. This tells them the airport elevation. Sometimes the runways are on a hill and the tower's down below. Sometimes blah, blah, blah. But these numbers don't always match up. Okay. So that's what that's telling them. Then there's just some basic information as to some of the regulations for the airport. It's like if this isn't working, then circling runway 7 and 16 are not authorized at night. You have to have DME and radar to shoot this approach. In-op table does not apply to standard ILS runway 3, standard localizer for runway 3, or Cat C landing minimums. And then when the local altimeter setting is not received, use the Hill Air Force Base altimeter setting. So it just gives us some information, gives the pilot, like, you will never look at that as a dispatcher and really care what it says there. But just some information for the pilot. This tells us that it's got MALS lighting approach light system. Okay. Just so you guys know, ALS is approach lighting system. Okay. You will hear us talk about this ALS a lot. It's a very common abbreviation we use, especially when we're talking about landing minimums. Okay. So there's our approach light system, our ALS. This is our missed approach procedure. Okay. So this is them turning up. They're going to climb to 4,900 feet, and they're going to do a climbing left turn to so they're climbing to 6,000 feet, and then they're going to fly direct to the Ogden VOR out here. Okay. Or Ogden Vortag VOR. Okay. Then once they get lined up with the Ogden VOR, they're going to climb to 13,000 feet off the Ogden 263 radial to the Moint intersection. So there's an intersection somewhere out here. They're going to climb to that intersection. That's 15 miles from the VOR. And then they're going to climb. If they haven't reached that 13,000 feet, they're just going to sit there and hold and climb till they hit that 13,000 feet. And then air traffic control is going to say, okay, you're cleared back in to start the approach, and then they'll start the approach again. Okay. So that's the instrument approach, or the missed approach procedure. Okay. Gosh, why does this thing come up? It's making me angry. Okay, ATIS. This is our automated weather information system. Okay. So the pilot, he can turn into his comms radio, communication radio, to 125.55, and it gives them weather information for the airport. Okay. These are the frequencies he's going to use. So 121.1, this is what our commercial traffic always uses. This is military. Don't worry about that. Okay. 121, this is air traffic control's frequency. Ogden Tower frequency, 118.7. If their tower is closed, I'm sorry, this, getting ahead of myself. Okay, this is called the Common Traffic Advisory frequency. So their tower and everything's going to be tuned in to that 118.7. This is where we're going to talk to other pilots, air traffic control, so on. Okay, once we're near the airport. Okay, ground control. This is if when we're on the airport, we're taxiing to or from the runway. That's the frequency we're going to use. And then this is the Unicom frequency. So when the tower shuts down at night, this is the frequency that everybody uses. Okay. All right, so this is the overhead like I was talking about. Here's our airport. Here's our initial approach fix. Here's our intermediate approach fix. This is our final approach fix. Okay. This gives us some of our VOR information here. This gives us our localizer. You can see that this is the missed approach procedure. You're going to fly to the VOR, then out on the 263 radial to that point intersection, and then you're going to hold. Okay. This is what we call a minimum sector altitude. So if we're flying anywhere from 160 degrees from the Ogden VOR to 325 degrees, so we're flying basically, if we're flying in this sector, our minimum sector altitude, if we're anywhere over here, let me erase all this and clean it up. Okay, so 160, 325. If we are anywhere on this side, the minimum altitude in a 25 nautical mile circle, okay, 25 nautical miles, the minimum safe altitude we can be at and clear all of our mountainous terrain by 2,000 feet is going to be 11,000 feet, okay? If we are on this side and within 25 miles of the airport, the lowest altitude that we can be at safely and clear all obstacles is going to be 8,600 feet. Does that make sense? Kind of important. Here's our profile view again. We're going to get through NACO. Okay. Okay, cool. So let's look at our different types of approach lighting systems. This is very, very important. Let's go back here really quick. I just want to see. Okay. So let's jump to our approach light systems, okay? We've got ALSIF 1 and 2, okay? These approach light systems, just all of them together collectively, this will typically dictate how low of landing minimums we can have. So this ALSIF 1 and 2, typically you're going to see these at bigger airports like Salt Lake International, Denver, LA, San Francisco, bigger airports, right? And with these approach light systems, they can go below the standard ILS minimums all the way down. Sometimes if the airline meets the requirements, they can do what we call a Cat 3C approach, which is basically you can't see a single thing outside of the airplane until you're on the ground, until your wheels touch down on the ground. So their landing minimums are 0 miles visibility and 0,000, 0 feet ceilings. They can go all the way down to the ground. These airplanes are typically equipped with an auto land system, so the pilot doesn't even land the airplane. He's just there to watch the computer do its job. Okay. Pretty cool stuff. No, SkyWest is not capable of that. But I don't think we'll ever have the need for that, to be honest with you. So ALSIF 1 and 2. SkyWest does do Category 2 landings, which basically takes that 200-foot ceilings and 1/2 mile visibility that a standard ILS is and cuts it in half. Okay, takes it down to that 100-foot and 1/4 mile visibility. Just to show you guys how scary that is, we're going to watch a YouTube video. Yay! So, oops. Everybody pull this up in your Internet Explorer. Watch this video really quick. It shows you what it looks like from a cockpit, what a Category 2 approach looks like. Pretty crazy, right? I mean, when you could hear the computer call out 500 feet, and when it called out 500 feet, you couldn't see a single thing outside the cockpit. And you can hear the second in command, the co-pilot, you could hear him say approaching minimums, and then you hear it say 100 feet. The pilot says, landing, or they say approach lights. At that point, they're at like 150 feet. So from that point to when they touch down was a total of like 15 seconds, right? So they can't see the airport until like the last 10, 15 seconds before the wheels touch down on the ground. Pretty freaking scary. You know, it's something where you really got to learn to trust your instrumentation and let the plane do its thing. And you just got to remember that you're there to assist the plane. You are not the pilot at that point. So, yeah. They actually say that like your heavier airplanes, like 747, Airbus A380, things like that. Let's say they get down to those approach minimums. Let's say I believe it's a standard ILS, which is 200 feet, half-mile visibility. Okay. They decide to go around because they can't see the runway at 200 feet and half-mile visibility. And so they punch the throttles all the way forward. The aircraft will still touch down on the ground before the engines spool up with enough thrust to go around. Like, that's how little time they have when they hit those minimums. You know, it's crazy to think about that, at least for me. So yeah, so these approach light systems, you could see it in the video. You could hear the pilot call out, approach light system. That means that she could see the lights, the strobes going up. We call them chasers. You could see it chasing up there. Mausers, this is your standard ILS. Mausers and Malsifs. Oops, where did it go? Mausers, Malsifs, these are your standard ILS. And anything less is typically, I believe even Malsif. I believe Mauser's the standard ILS, and then Malsif or lower is going to be your lower, like, higher landing minimums. Okay. Here's your definitions. Mausers. Gosh dang it. Okay, Mauser, you can see it's Mauser stands for medium intensity approach light system with runway alignment indicators. That's one I would try to commit to memory. So, yeah. Commit that one to memory. That's what I'm saying. Okay, this is how the Jeppesen approach charts look, approach plates. A little bit different, but the same information once again, right? You've got your straight in ILS landing minimums. You've got your decision altitude or height. Okay. This right here, this is the altitude above sea level. So mean sea level, MSL. This is your AGL, above ground level. So this is what the pilot's going to read in the cockpit on his instrumentation, on his altimeter, is 200, or I'm sorry. This is what he's going to read on his, like if he's looking at AGL, this is what he's going to read on his altimeter right here. Is that 232 feet? 200 feet is how high he's going to be off the ground at that 232 feet he sees on his altimeter. Okay. So this is where our ceiling has to be. This is the minimums, remember? So here's our runway, our clouds up here, blocking the view of the runway. This cloud, they have to be at least 200 feet above the runway. Does that make sense? Everybody clear on that?
Yep.
This is
Yeah, I am, but you can't control the clouds. So what do? Go to an alternate?
so if he's coming in to land at this runway, he can't see the runway when he hits this 200 feet. If he can't see the runway, then he will do that missed approach procedure. Okay, he has to.
Okay.
A lot of times they try to hold over the VORs. They'll go into this holding pattern over the VOR. And they'll wait to see if the clouds move or if it clears up enough for them to do another approach. Sometimes pilots, they'll give it 2 or 3 chances even. And then if they just can't see the runway, you know, and they start running a little low on fuel, at that point they'll go to their alternate airport. So
Got it. Okay.
so this is like that safety altitude, right? So this is them. This is where the FAA says this is what's safe for you guys to make that decision. Am I landing or am I not? Half-mile visibility. Sometimes we have fog, right? So we've got this weird fog layer over the runway. Okay, if we can't see a half mile down this runway, no bueno. If the weather is reporting less than this half mile, no landing. We can't even start our approach. The pilot can't even start the approach to the runway if there's not at least 1/2 mile visibility. This is what we call RVR. So I think it's a little later in this PowerPoint even. That there, let's take a look. Here's the runway, okay? Right here, and right here, so actually, I'm sorry. There's 4 of them. So here's our runway. Here's the machine, here's the machine, here's the machine, here's the machine, here's the machine. Okay, this part, say we're coming in from this direction, okay? Flying our airplane, okay? Flying our airplane, we're landing this direction. This one is called the touchdown zone. This is our midpoint. MID, not an O. And this is our rollout. Okay, so these machines, like if you're looking at them, they got this laser here in the center of the box. They line them up along the runway, one at each one of these points. And what this does is it shoots the laser down the runway, and it says, this is how far we can see down the runway without any obstruction. So the visibility, this is like if you were standing at the end of the runway and you are looking down the runway, this is measuring how far you can see down that runway. Okay. RVR, this is one saying I want you guys to write down, know very well. RVR is always controlling. Write that down. RVR is always controlling. So let's say our weather report, says that we've got 1/4 mile of visibility. We look on our landing minimums here. It says we need 1/2. Can we land? Nope. Okay. But down here it says R7 left. So this is for runway 7 left. R7 left is reporting 2,800 feet. Okay. It'll look something like that. This is telling us that the runway visual range, so these little boxes that are shooting the laser down the runway, can see 2,800 feet. Okay, so it gives us this 1/4 mile earlier in the METAR. Okay, in our weather report, it says that we can only see 1/4 mile, but then we have this RVR reading of 2,800 feet. We can land at that point because this says that we have to have an RVR of at least 2,400 feet. Okay, does that make sense?
Yeah, that makes sense.
Okay, the reason why is because the machine, the METAR machine, sometimes if we're looking down, on an airport, so this is Salt Lake International Airport. Okay, you got these 3 different runways. The METAR machine may be clear over here on this side of the airport. So the visibility may be 1/4 of a mile over here. That METAR machine may only be able to get that 1/4 mile. But, if we're landing on this 3-4 left here, okay, if we're landing on 3-4 left, our RVR may be a lot higher, a lot better than the reading that we're getting over here on this side of the airport. So that RVR, always controlling. And the same goes the other way. Sometimes that station that's over here, you got your runways again. Okay. Sometimes that station may be reading 1/2 a mile, and our RVR over here is only reading 1,800 feet. At that point, can we land? We've got a 1/2 mile over here, but we only have 1,800 feet. We can't land still, right? So that RVR number, if we get an RVR value in our METAR, that's always the controlling number, period. Doesn't matter. We will always use that number over the visibility in the METAR. Okay. So this is the Jeppesen landing minimums. This is what it looks like. Okay. Here you can see this is our straight in. It says straight in landing for runway 7 left. Okay. Here's our minimums. We've got our. Whenever we're looking at minimums, we're always going to look here first. This is our 200-foot ceiling and our 1/2 mile visibility. That's whenever somebody asks you what are the landing minimums for runway 7 left, straight using the straight in ILS, you're always going to say it this way. You're going to say 200-foot ceilings, 1/2 mile visibility. Okay, that's if that's what it says here. So 200 feet and then 1/2 mile visibility. Okay, that's if nothing's broken. Okay, we use NOTAMs. Sometimes these airports have broken stuff on them, right? So let's say that approach lighting system isn't working. Okay, these are our new landing minimums. We can still keep our 200-foot ceilings, but now our visibility, we have to have 3/4 mile visibility or 4,000 feet of RVR, runway visual range. Okay. So that's using our straight in ILS. Okay. So remember, an ILS is a precision approach. So it's giving us that crosshair, lateral and vertical guidance. Okay. Here's our lateral guidance is actually this straight up and down one. This one, this horizontal line is our vertical guidance. Okay. If we're looking at the instrument. So let's say that the glide slope or our vertical guidance goes out of service. Okay. So all of a sudden, we're not getting the full crosshairs. All we're getting is this lateral guidance, right? So side to side of the runway. Here's our runway over here. We're only getting the information. Am I to the right or to the left of the runway? What does this approach all of a sudden become? If it's a precision approach and part of the precision approach is broken, what does it become? Take a stab.
A non-precision?
Exactly, a non-precision approach. Okay, now we are only receiving the lateral guidance. Remember, precision, both vertical and lateral. Non-precision, only lateral. Okay. So, what do you think happens to our landing minimums if our glide slope breaks on the ILS?
They go up.
Exactly. Our landing minimums increase. Okay. So, if our glide slope breaks, our ceilings go from this 200, okay, to the 388 feet. Okay. This says 388 feet, but if somebody ever asks you what are my landing minimums with my glide slope out, and you see, or what are my landing minimums, and you have anything extra, you know, it's not an even hundreds, or I guess that's the wrong way to put it. It's not a hundreds. We always round to the nearest hundreds. So, or we always round up. I'm sorry. So even if it's 301 feet there, we'll always round up to 400-foot ceilings. Okay. So if somebody ever asks you what are your landing minimums and you've got like 301 or 320, you'll always round up. You'll just say my landing minimums are 400 feet and half-mile visibility. Or if my runway alignment lights are out, then it's 3/4. If my ALS is out, then I have to use 1 mile. Does that make sense?
No, why are there two numbers there? Why is there a 420 and a 388?
So if we look here, this is telling us minimum decision altitude. So once again, this is reporting MSL. This is the altimeter reading inside the airplane. He's looking at his instrument. Okay. In the parentheses, we can see the height. So this is height above terrain, or AGL.
Okay.
Okay, so this is our MSL reading. This is our AGL reading. So
in this particular case, we're about 30 feet above sea level.
Yeah. Yeah.
Okay.
32 feet or whatever. Yeah. So this airport, Barb's. This looks like Los Angeles. Yeah, I believe this is Los Angeles. So they're like right at sea level almost, you know. Okay. So once again, this is the full functioning ILS. Okay. The glide slope and the lateral guidance are working. Our vertical and lateral guidance are working. All of our lights are working. These are our minimums. Okay. Let's say the runway alignment lights are broken, or the approach lighting system is broken. These are now our visibility minimums. Okay. Let's say that the glide slope is not working. This now becomes our ceiling, and if nothing else is broken, half mile. If our rails are broken, 3/4. If our approach light system's broken, 1 mile. And that's, remember, with our CRJ 700, we're a Category C aircraft. Okay. This box here to the far right is our circle to land minimums. Don't use them. Just ignore this box. Unless somebody asks you a question, which I don't think they ever will. But if somebody were to ask you, what are my circle land minimums using the ILS for runway 7 left, this is where you would look. But you won't be asked that question, so just dump that. Okay. When I talk about these categories here, this is talking about the approach speed for your aircraft. That's what dictates which category, which minimums you're going to be using. So you can see here, this kind of is a cheater here. If your approach speed is 90 to 120 knots, you are a Category A aircraft. Okay. If your approach speed is from 120 knots to 140 knots, or I'm sorry, I'm doing that backwards. 90 knots or less, okay? 90 knots or less, you're a Category A. If you're 120 to 190 knots, you're a Category B. If you're 140 knots to 120 knots, you're a Category C. If you're 165 knots or less, then you're a Category D aircraft. Okay. Pretty much this one's just a catch-all. Let's say it's like, I don't know what aircraft would have an approach speed higher, but this is just like all others, okay? The important thing with the category of airport or of aircraft, just know that the CRJ 700 will always fall in this C category. So your minimums are always going to be right there. Okay, does that make sense? Everybody understand that? So if it sections off into these other boxes like this, your minimums will always, you'll just follow that category C all the way down. Okay. Okay. This is how Jeppesen chart looks. You know what? Screw that. We're just gonna pull one up. Okay. Somebody name an airport, a fun airport. Be imaginative.
Grand
Jersey.
Rapids.
Grand Rapids.
KJFK.
KJFK. Oh man, I hate JFK. Hate JFK. Hate LaGuardia. Hate Newark. I don't know why anybody would want to fly into those airports.
Everybody hates them.
Yeah, they're horrible. So busy. Okay, so here's your Jeppesen chart. Okay, Just really quick, let's look at this really. You can see over on this side, right here, okay, these are all of our different charts for this airport. This 10.7 chart gives us general information about the airport. 10.7 alpha gives us a little more in depth. It's just a continuation of 10.7 chart, okay? 10.9, this is the one that shows us the top-down view of the airport. 10.9 alpha gives us some information on our minimums. And then here's our ILS approaches, okay? We have 3 available ILS approaches. RNAV uses GPS or satellite, okay? So these are satellite GPS approaches. Okay. In this class, if you see RNAV or satellite navigation anything, and I think I've said this before, we're not using it. Okay. And then down here on the bottom, we see our lonely little VOR approach. Okay. So ILS, satellite GPS, and VOR. Okay. Who can tell me which chart gives us our lowest landing minimums? Come on, y'all.
Would it be the ILS chart?
Yeah, ILS. There we go. Okay. I'm asked that a lot. What chart gives us our lowest landing minimums? ILS. Yay. Doesn't matter which runway. We're going to use the runway that favors the winds. Remember, headwinds, good stuff. So if our headwind is coming from the west, going east, or I'm sorry, the east going west, then we're going to use this runway 8 right ILS chart. Sometimes this Jeppesen like freezes up on me. I want to see the whole chart. Oh my Lanta. All right, we'll use 2.6 left then. For some reason, it's not pulling up. Come on, just a couple more. Don't do this to me. All right. Anyways. Gosh. Let's dissect this chart a little bit. Remember that pilot briefing box from the NACO chart? Here it is. Pilot brief. Okay. Here is something important to remember on your instrument approach plate. This is the navigational aid that this instrument approach is predicated off of. So not only is it giving him the frequency, it's giving him the type of navigational aid that is being used. So this is a localizer. Here's the identifier for the station, and this is the navigational radio frequency that the pilot tunes into. Okay. So this is important because of something we're going to learn called the 1 nav aid, 2 nav aid rule. Okay. So whenever I say what navigational aid is this predicated off of, this approach predicated off of, you're always going to say, you're going to look in this box and you're going to say it's localizer, and the identifier is IGGR. If you see this I at the front, that means it's a localizer. Okay. Once again, it's giving us our weather. This is our approach frequency. This is Chicago Center, Common Traffic Advisory. Our ground frequency. This is the important one. If there's one box that you remember in the pilot brief, please let it be this one. Okay. Here's the second most important box in the pilot brief. These are pretty much the only two boxes as dispatchers we will ever reference at all. Okay. This box here, that's our MSA. This is our minimum sector altitude. Okay, remember that. That is something that you're going to be asked about on the oral part of the practical. Okay, what is our minimum sector altitude if we're 160 degrees from this, from the station, 2,500 feet. Okay. Remember that this circle is 25 nautical miles around. Okay. All right. This part, this is our graphic, right? This is our top-down view of what our approach looks like. Okay. You can see the VOR. This is your localizer or ILS. Okay. This is what your approach profile, or I'm sorry, your top-down view of your approach will look like. Okay. Sometimes the pilots, they'll approach the airport from this way, then they'll come, do this loop, and that's when they'll start their approach. I know runway 1 in St. George, this is what the approach looks like. Okay. Here's your missed approach procedure. You can see it there. Here's what your holding looks like. Alternate missed approach. Okay. Scroll down here. This is our descent profile. Okay. You know that loop I was talking about? While you're doing that loop, you're descending to 2,700 feet. Then you're turning to 267. And you're flying at 2,700 feet. You're 10 miles away from the airport. You're staying at 2,700 feet on the 267 degree radial to the final approach fix. Okay, this is where we start that final descent to the runway. Let's say that he goes missed. This is where he goes missed, right here. Okay. This right here is a graphical representation of the missed approach procedure. Oops, I'm sorry. This box right here. This is the missed approach procedure just in graphical form. So you're going to climb On your runway heading, you're going to climb to 1,300 feet. Then you're going to make a left turn, climbing left turn to 3,000 feet. And then once you're over the VOR, you're going to hold over the VOR, okay? Terps, okay, this is our straight in landing minimums for runway 26 left, once again. This is talking about the altimeter setting, okay? So if we have the Gallagher altimeter setting, you know, we can use this dual VORs required. Without Gallagher, we just go with the information that's already here. Oh, and that's if the glide slopes out. Notice that it's only over this section of the chart. Okay, you can kind of look at these this part as like an Excel spreadsheet, rows and columns. So these columns here, this is with the Gallagher, this is without Gallagher. If you're using the Gallagher here, you have to have 2 VORs installed. 2 VOR radios, receivers installed in your aircraft. Okay. Here's your straight in ILS approach minimums. You got 200 feet, half-mile visibility. Okay. One thing to kind of note here. So, you know, going back to your question earlier, you can see your decision altitude. You're a lot higher MSL on this approach. But once again, your decision height is still 200 feet. So you make that decision 200 feet above the ground. Half-mile visibility. You can see this number 1 here, bolded in there. Okay, whenever you see these bold numbers here, that means that there's always going to be a note at the bottom. Okay, you saw it with Gallagher here. You can see 2 VOR receivers required. Well, the number 1 refers to the number 1 up here, and it's saying that we can go down, you know, standard is 2,400 RVR. We can go down to 1,800 feet RVR if we have a flight director or an autopilot or a heads-up display. Okay. If we have those installed in our airplane and we are using them down to that 200 feet, we're allowed to use 1,800 feet RVR. Kind of nice, huh? Gives us a couple hundred extra feet of cushion there. How does everybody feel about it? Confused? Off your rocker?
Yeah.
Or do you guys feel good about it?
Definitely gonna have to go through and watch this one again. There's a lot to know on these charts.
Yeah.
Exactly.
So, that being said, let's break down what's important for you guys to know on these charts. I mean, it's all important to a point. You know, everybody's a winner kind of mentality here. But here's what you need to be able to, as a dispatcher, this is what you're going to be using 90% of the time. You need to know that and that. Okay. And then the only things that you're going to use other than those 2 things as a dispatcher, or the only other thing that you're really going to use as a dispatcher is going to be this right here. Okay. So know how to get your landing minimums. That's like the key. So if I say, what are the landing minimums for straight in ILS on runway 26 left? Come in here, runway 26 left, straight in landing minimums, 200 feet, half-mile visibility. That's what I want to hear, okay? What if I say, I want you guys to answer this one. What if I say, what are the straight in landing minimums for runway 26 left with the glide slope out of service, and you have Gallagher? What are our landing minimums? Remember category C as well. Always category C.
Ceiling's 400 and visibility is a half mile.
Okay, so where are you looking?
The second column with Gallagher, and then with rail, and C.
And then right here, right?
Right.
Simple. You nailed it. 400 feet, always round up, right? If it's not at the 100, if it's not at the hundreds, always round up. Okay. So 400 feet, half mile visibility. Beautiful. Okay. What's our straight in landing minimums for runway 26 left with the full ILS, but our ALS is out of service? Someone else this time.
What was it again?
So we've got straight in landing minimums for runway 26 left using the full ILS, but our ALS is out of service.
An RVR of 4,000. Yeah, 4,000 or 3/4 mile.
Okay, what's our ceiling?
200 feet.
200 feet.
200 feet. Good. There you go. Okay. Pretty simple. That's going to be the absolute most important part. I can't stress it enough. Of your job as a dispatcher is being able to read landing minimums. Okay. This is where legal to go, all your legalities tend to fall. This is where probably the most violated FAR in the dispatch world is like, do I need an alternate, or even if I'm legal to go? Legal to go always comes first, then do I need an alternate comes second. Okay, determining legal to go is all determined off of these right here. Okay. Do I need an alternate? How do we know if we need an alternate? When do we require an alternate?
The 1, 2, 3 rule. At least 1 hour before and after arrival of ETA, at least 2,000 feet above the runway, and visibility has to be 3 miles.
Good. Okay. Good. So, as you guys noticed, that has nothing to do with legal to go. That had nothing to do with landing minimums. That's an animal of its own. 1, 2, 3 is for alternates. This is for landing minimums. This is legal to go. Okay. We will hit this another 100 times before you guys are done with this class. So if you don't understand it fully now, talk to me. Just know also that we're going to continue to hit this all throughout the course. So let's go back here. Let's try to finish off this PowerPoint. Okay, full approach. Not going to worry about that too much. Actually, I don't want to confuse you guys anymore, and it's not really anything that we care about in dispatch, okay? Circling procedure, like I said, it's just rather than coming straight into a runway, they circle in and land on the runway. We try to avoid these once again. A lot higher landing minimums is the important thing to remember with circle to land, okay? That's pretty much the only thing that I want you guys to remember with circle to land minimums is that circle to land minimums are always going to be higher than our straight in. And they're typically really horrible. Okay, landing minimums at our departure airport. Okay, this is talking about a takeoff alternate. Okay, if the weather, and we talked about this in the FARs, okay, if the weather is below landing minimums at our departure airport, we are required to list a takeoff alternate. Okay, kind of important, right? So the reason for that is if something is to go wrong on takeoff and we can't turn around and land at our airport because the weather's below minimums, then we have to have somewhere to go. You have to have that planned out. Okay. And yes, we can always take off like our landing minimums. Our takeoff minimums are a hell of a lot lower than our landing minimums. Like pilots, basically, you got to be able to see what's going on in front of the airplane, and that's it. So a lot of times we refer to it as adequate visibility. If the pilot lines up on the runway and says, I got adequate visibility, he can take off. Okay. Landing minimums at the destination airport. Okay. So if the weather reports are below the landing minimums at the destination, like if they're forecasted to be below our landing minimums at the destination, we're not legal to go. We can't even take off. Okay. So let's look at our weather report really quick. Oh, okay, good. Okay. Here's our TAF right here. Okay. Actually, do you know what? I've made worksheets for you guys to practice legal to go stuff. Okay. Okay. So let's look at this TAF line. And we're going to get into these a little down the road. Okay. This TAF says that from 2 o'clock Zulu to 3 o'clock Zulu, the visibility is going to be at a 1/4 mile. Okay. Standard ILS, the lowest we can go is 200 and 1/2 mile visibility, right? So that being said, 1/4 mile visibility is less than 1/2 mile visibility. If our ETA falls between 2 Zulu and 3 Zulu, we cannot take off. We can't even take off and go to that airport if our ETA falls in that time. Not legal. Okay. When we're determining legal to go, we're only using the visibility. Okay. Ceilings, like you said, we have no control over the clouds, right? So, just because it's saying that it may be, let's say that it's reporting ceilings of 100 feet at our ETA, we don't know if that cloud, if we're looking at our runways here, let's go back to Salt Lake Airport, we don't know if that cloud is over this runway, is expected to be over this runway. We don't know if it's expected to be over this runway. We don't know if it's expected to be clear over here off the field. They're just saying that there's going to be a 100-foot ceiling at some time during that hour. So we don't know when or where that cloud's going to be, so we just don't even care about the ceiling on our TAF when we're determining legal to go. We only care about the miles of visibility because that's typically pretty solid. Like when these are on the TAF, that's typically like the only information that we ever get that's ever semi-accurate at all. All the other stuff is like throwing a dart at a dartboard, Especially when I throw darts at a dartboard, I may hit the wall 4 feet to the right. Just don't know. Okay. So that's pretty much how they determine TAFs. It's like some guy sitting at a computer and he's going, "Oh, we'll probably get a couple clouds over here at this time." So, yeah. Let me see. Actually, okay. And this last part, just ignore whatever. We'll get legal to go. We're gonna work on that. You guys are gonna be sick of legal to go crap, but you guys will be pros at it. Okay. So here's your airport sketches and diagrams. We've already kind of gone over these a little bit tonight, so I'm gonna kind of go fast through these. There you go. We'll get into those a little bit more. Break down a little more information as we go through the class here. We don't care about visual. We don't care about RNAV. ILS categories. Okay, category 1. This is instrument rated, equipped with the proper avionics. Right. Typically have to have DME, VOR, and radar to do a category 1 approach. Our minimums are typically going to be 1/2 mile visibility and 200 feet. Okay, remember this is ILS category 1. Okay, so this is what we're using for this class. We will always be category 1 on our instrument approach procedures. Okay, category 2. The airline is required to carry a special certification saying that my pilots have been trained. Okay, not only are the pilots, or not only does the airline have to have this certification, but the pilot shooting the approach has to have the certification as well. Okay, so that the certification just says that this person's been trained on how to do the category 2 approach, and it's been approved by the FAA saying, you know, this airline's got the capabilities, and they've, you know, their pilots are trained well enough on how to do the category 2 approaches. Okay, as you can see, it cuts these minimums in half. I already said this before, but our RVR goes down to 1200 rather than 2400, which also makes our visibility 1/2 mile. Our decision height is 100 feet above the ground. Okay. Category 3. Okay. Category 3, once again, special certification. There's also very specific equipment that is required to be on the aircraft. They have to have a HUD. They have to have a auto land system, coupling, you know, all of these different pieces of equipment on the aircraft for them to even be considered eligible to shoot a Category 3 approach. But once they're certified, they're going to be certified as either an A, B, or a C Category 3 airline, okay, or even aircraft, or even pilot, okay. This one reduces their minimums by half again, about. Category B lets them go down to 150 feet for their RVR, and 0 for Category C. With the ceilings, it's basically there's no requirement on ceilings, just on RVR. So 700, 150, and 0.
What was DH?
Decision height. So that's the height
Okay.
above the runway, and that's that decision height. You didn't hear it on that video that I showed you, but what you'll hear in the cockpit when you guys are dispatchers and you're jump seating, you'll hear whenever they're shooting an ILS or any approach, really, you'll hear the computer say like 500, and then a couple seconds later it'll say minimums. That means that they're at the minimum altitude where they have to make that go, no go decision. Am I going to land? Am I going to continue with the landing, or am I going to do go missed? Am I going to do a missed approach? Okay. They always put the minimums for the runway that they're going to be using into the computer, and the computer will tell them when they're at that minimums. Okay. Some runways have additional lights. Okay. Here you have your center line lights. You got your touchdown zone lights. You've got, this is your end of runway lights. I can't remember what they're called. Runway alignment lights. You got hurls. Just there's a dozen different combination of lights that you can have at a runway. Okay, we talked about this ALSIF 1, ALSIF 2. These are going to be your lowest visibility runway lights. Oops. Crap. Okay. Why does it keep doing that? Okay. Like I said, touchdown zone lights. You got your center line lights running up the center. Okay, these are the rails, runway alignment. But yeah, you can faintly see these blue lines or blue lights here. Those are your taxiways. Okay. These red lights down here at the end, they're telling the pilot, hey, you're 1,000 feet from the end of the runway. You've only got 1,000 feet of runway left, so you better be stopping pretty freaking quick here. Okay. Here you can kind of see the two lights of the PAPI system. So the PAPIs is a 4-light system. You'll have 2 red lights. This is what you want to see when you're anyways, and then just pretend that this is white. Okay. This is what the pilot wants to see. This means that he's approaching the runway. Remember, here's the runway here. This is our glide slope of 3 degrees. 3 degrees. Okay. This means that he is right on that glide slope. If he sees 2 red, 2 white, that means he's right on the glide slope. Okay. Let's say that one of these lights here turns red. Now that means that he's lower. Okay. We in aviation we say red, you're dead. That's because he's getting too low. Okay, if all 4 of them are red, that means he's really freaking low. Okay, let's say that he has 3 whites. That means he's slightly above that glide slope. If he has 4 whites, that means he's really above the glide slope and that he needs to correct. Okay, so white, stay in flight is the saying for that. Not that you guys really need to know that, but just fun information for you guys. Oops. Oh my gosh. Okay. Here's the difference between a Cat 2 and a Cat 1 approach. Okay, on this chart, you can see this is the ILS, or localizer approach for runway 16 left in Salt Lake City International. This is the Cat 2. You can see the Cat 2's in a parentheses there for the same runway. So something kind of interesting to note here. Remember how I said this box shows you what navigational aid the approach is predicated off of? Look at that. Same frequency, same exact navigational aid. It's just they'll use the same exact equipment. It's just if they're capable of a Cat 2, their landing minimums are lower. Okay. But other than that, everything looks identical. They'll approach the runway the exact same way as they do in a Category 1 approach. Okay. We already dissected the jet chart, and that's the end of this PowerPoint. How do you guys feel about all that? Burnt out?
Yeah, a little bit.
It's okay. You guys can be honest with me.
Throughout the week, though, it's starting to make more and more sense. Like it's starting to connect a little more. It's a little easier to understand.
Yeah.
'Cause at the beginning of this week, I was lost. Now it's like, okay, I kind of see where everything's starting to connect a little bit.
So here's your guys' homework for tonight, okay? I want you guys to come into this day 4 navigation stuff. Okay, I want you guys to watch these videos here. Super easy. I think they're each like 15 minutes long. Just like play them, listen to them. They'll go over the same information that we just went over, but it's always good to hear it from somebody else. I don't sit here and script everything for you guys, and sometimes I confuse myself, as you guys can see. So I'm not reading this crap off of a script. These other guys are guys that have been, these are the guys that probably wrote the laws, wrote the FARs, put together the navigational charts or whatever, and they'll read off a script, and it may make more sense to you guys. So please watch the videos. It will help increase your understanding of all the information we just went over. Okay. It's really, 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 really good information. And like I said, landing minimums are your job as a dispatcher. Like, you are supposed to be the guy to go to when it comes to driving landing minimums. And if you can't do that, you're going to struggle as a dispatcher. So get comfortable with those charts. Get comfortable understanding the information on them. Okay. This information just helps you understand the information on the charts. Okay. So please watch them, and it'll just help you guys out. Tomorrow, we didn't get to this other PowerPoint, so I'm just going to move this one over into tomorrow's folder. And we'll go over this one first.
Did our quizzes get put in?
I'll have them in after this class. I built the folders and everything on the lunch break. I'll get them in after class tonight. So after we get off.
Right.
And I'll share the folders with you guys too. That's the other thing I have to do. So yeah, expect those tonight. We'll go over these. This is the one that we went over tonight, so I can delete that one. Okay, so we're actually on track. We didn't fall behind at all. We'll go over this tomorrow. Which is the SIDS and stars. Just 1 second. Okay, so we're going to go over that information tomorrow. We're going to learn about air traffic control probably on Monday, and we'll probably take the quiz on Tuesday. So Monday we'll probably do the review. Let's see here. Just want to see. So let me ask you guys this really quick. Yesterday, Adam went over the types of ground-based navigation, right? You went over what a VOR is, NDB, ILS. Yes. What did you guys go over yesterday? Bueller.
I'm still trying to take in what I took in today, so sorry.
Who remembers what you guys went over yesterday? Was it did you guys go over this information here?
Yes.
Yeah, it was a lot of stuff on charts. Like, I think we watched 3 videos, and so a lot of stuff on charts.
Let's see here. This is the stuff you guys went over. Spaces. Okay, you guys went over it on Monday. You guys remember this PowerPoint?
Yeah.
Yeah.
Davis talked about it. Okay, good. Yeah, so that means that, let me go back to the outline here. Nah. Okay. So yeah, tomorrow we'll go over this information here. And hopefully cover this information. Monday, you'll probably review for the test. And then yeah, Monday you'll review for the test. And then on Tuesday you guys will take the quiz on the navigation stuff. Sound good?
Yeah. And then that frees up the weekend a little to work on ADX. So that's really good, actually.
Okay. Good. All right. Well, get ready for some more of this fun stuff tomorrow. I'll let you guys go tonight. So.